welcome to Solving Trig Equations with Caitlin,
Jess,
and Jasmine, who's currently in Florida right now.
here are some tips.
Tip number 1. If it's a fraction set equal to 0, set the numerator equal to 0.
Tip number 2. If it's a fraction set equal to 1, set the numerator equal to the denominator.
Tip number 3. Put it in terms of one trig function.
This means to put it in terms of sine, cosecant, cosine, secant, tangent, and cotangent.
Tip number 4. Square both sides.
But wait, there's more!
Squaring both sides may introduce extraneous solutions, so you have to check your answers.
Now, how does one solve a trigonometric equation?
Well, Jess, there are many different ways to solve trig equations.
One way is collecting like terms.
Another way is by extracting the square root.
You can also factor.
You can also rewrite it with a single trig function.
When working with quadratics, you can factor them.
You can also square and convert it to a quadratic.
Now for the one that we all love, you can use your calculator.
Here's an example of a simple trig function. 2 sine x minus 1 equals 0. First, add 1 to both sides. So you have 2 sine x equals 1. Then you want to get sine by itself, so you divide both sides by 2. So you have sine of x equals 1/2. Then you think of your unit circle. When working with the unit circle, cosine represents the x value, and sine represents the y value. And you see which number has a sine of 1/2. Pi divided by 6 does. But you can't forget about the other 3 quadrants, because 5 pi divided by 6 also has a sign of positive 1/2. But when the problem doesn't restrict you to numbers only between 0 and 2 pi, you can go around the circle an infinite amount of times. But who wants to do that? So we just add to our answer plus 2 pi k to indicate that you can go around the circle an infinite amount of times. Now 2 pi k only works when k is an integer. So the answer to our problem is pi divided by 6 plus 2 pi k and 5 pi divided by 6 plus 2 pi k. Now remember, this only works when k is an integer. Okay, so the first thing we're going to be doing is adding 1 to both sides. You would then have 3 tangent squared x equals 1. You would divide both sides by 3 and get tangent squared x equals 1/3. To get tangent by itself, you would have to take the square root of both sides. When you take the square root of a number, remember to add plus or minus. Now radical 1 equals 1, so change that to 1. With tangent is to take both the numerator and denominator and put them over 2 to get numbers that you're used to seeing on the unit circle. Now looking back at the unit circle, we see that pi over 6 and 5 pi over 6 are both solutions to the answer. Knowing that there are no restrictions, make sure you add plus 2 pi k to all your solutions. This only works when k is an integer. Seven pi divided by 6 and 11 pi divided by 6 also work. Plus 2 pi k when k is an integer. So here we have the quadratic. 2 sine squared x minus sine x minus 1 equals 0. Now, Sine x is not fun to work with, so let sine x equal p. That makes the problem 2p squared minus p minus 1 equals 0. Now from here you factor the quadratic. And you get 2p plus 1 times p minus 1. Now where is sine of x negative 1/2 and where is it 1? Well, sine of x is negative 1/2 at 7 pi divided by 6 and 11 pi divided by 6. Sine is 1 pi divided by 2. But there were no restrictions, so to all of your answers, you have to add plus 2 pi k when k is an integer. First, you're going to write down the problem. Sine of x plus the square root of 2 equals negative sine of x. Then you're going to combine the like terms, as you can see. You would subtract the square root of 2 and add sine of x. So you would get 2 sine of x equals negative square root of 2. And then you would square both sides, and you would come up with 4 sine squared of x equals negative 2. Then you can see in step 4 that in order to get sine alone, you would divide by 4 on both sides. So once you get sine squared of x alone, you would take the square root of both sides in order to get sine of x alone. You would get negative radical 1 over radical 2, and then you would have to take the radical out of the denominator, and you would come up with negative radical 2 over 2. So then you would go to your unit circle, and you would find where sine of x equals negative radical 2 over 2, and you would see that it's 5 pi over 4 and 7 pi over 4. And in order to get the rest of your answers, you would add 2 pi k for each. So now you have the problem 2 sine squared x plus 3 cosine x minus 3 equals 0. But you don't want to work with sine and cosine, so you're going to rewrite it in terms of one trig function. So you know that sine squared x is really 1 minus cosine squared x because it's an identity. So you're going to write 2 times 1 minus cosine squared x plus 3 cosine x minus 3 equals 0. Then you're going to distribute the 2. So 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. You can combine like terms, 2 and negative 3. 2 minus 3 is negative 1. So you have negative 2 cosine squared x plus 3 cosine x minus 1 equals 0. Now you have a quadratic, but you don't want to work with cosine, so you're going to let p equal cosine x. Now it becomes negative 2p squared plus 3p minus 1 equals 0. Then you can divide by negative 1 and get 2p squared minus 3p plus 1 equals 0. Then you can factor this to 2p minus 1 times p minus 1 and set them both equal to 0. Then remember that p is really cosine, so you can set 2 cosine minus 1 equal to 0 and cosine minus 1 equal to 0. Where's cosine 1/2 and where is cosine 1? Cosine is 1/2 at pi divided by 3 and 5 pi divided by 3. Cosine is 1 at 0. And there were no restrictions, so you have to add 2 pi k when k is an integer. Here we have the problem 2 sine squared 2x equals 1. The first thing you'll do to try and get sine by itself is divide by 2. So you'll have sine squared 2x minus equals 1. I'm going to divide this by 2 and the 1 by 2. Next thing you'll do to try and get it by itself is take the square root of both sides. Now you see here that we have a radical in the denominator, which we have to get rid of. So what you'd have to do is rationalize it by multiplying by radical 2. Then you would get sine 2x equals plus or minus radical 2 over 2. We see here that we have the 2 next to the x, meaning that we have to go around the unit circle twice. These are all the answers you would get after going around the unit circle twice, but since we're not solving for 2x, we would have to multiply both sides by 1/2. Doing so would then change the denominators to all these answers to 8.